Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. Today we are going to learn about the shapes of different orbitals in the subshells. In the previous lectures, we have learnt about the quantum number which gives the address of the electron. The principal quantum number n tells about the main energy shell, azimuthal quantum number L tells about the subshells in the main energy shell. Magnetic quantum number tells about the orbitals in the subshells. So first let's recapitulate some rules, then we will talk about the shapes. So here I am writing a table in which I am going to specify the values of L and the M. So firstly I am writing L to be here. Then what's the value of M? The value of M ranges from minus L to plus L. Now the values of L are 0, 1, 2 and 3. The 0 value specifies S subshell. The 1 value specifies P subshell. The 2 D subshell and 3 F subshell. So now let's evaluate the value of M for all the values of L. Now let's first talk about the 0 value for the S subshell. The value of M will be only 0. We got only one value of M, that is 0. It specifies we have only one orbital in S subshell. Only one orbital in S subshell. Now let's talk about the P subshell. The value of L for P is 1. So the value of M will be from minus 1 to plus 1. So it will be minus 1, 0 and the plus 1. Here we got the three values of M which specifies we have 3 orbitals in P subshell. Now let's talk about the D subshell. The value of L for the D subshell is 2. So the value of M will range from minus 2, minus 1, 0, plus 1 and the plus 2. We got the 5 values of M for the D subshell. That stands for we have 5 orbitals in D subshell. Now let's name these orbitals. Let's specify some symbols for the different values of M. Now let's talk about the P subshell. The minus 1. The minus 1 stands for, in case of P, the minus 1 stands for PX. 0 stands for PZ. Plus 1 stands for PY. Now in case of D subshell, the minus 2 value stands for DXY. Minus 1 stands for DYZ. 0 stands for DZ square. Plus 1 stands for DZX. And plus 2 stands for DX square minus Y square. So these are the specifications of all the values of M in case of P subshell and a D subshell. We got the names of different orbitals like Px, Py, Pz, Dxy, Dyz, Dz square, Dzx and Dx square minus Y square. So now let's talk about the F subshell. The value of L for F subshell is 3. So its value of M will range from minus 3 to plus 3. Minus 3, minus 2, minus 1, 0, plus 1, plus 2 and a plus 3. In total we got the 7 values for the F subshell. So that stands for the F subshell has 7 orbitals. Has 7 orbitals. Now we will talk in detail about the f orbitals in the further lectures of f block elements in inorganic chemistry. The shapes of f orbitals has not a major role to play comparatively s, p and d orbitals. So now let's talk about the shapes of the orbitals of s, p and the d. Now firstly is an s orbital. Now the s orbital does not have directional preferences. Does not have directional preferences. So we don't need to specify the directions, that is x, y and z for the s orbitals, and the shape of s orbital is spherical only. So see the diagram carefully. What I'm going to do, I'm going to make the s orbital and that's spherical in shape. So that's the s orbital, which does not have any directional preference. Now let's talk about the p orbitals. P orbitals have directional preference. P orbitals have directional preference. The shape of p orbitals are dumbbell shape. The dumbbell shape is like, assume this is the nucleus, that's the one lobe and that's the another lobe. The word is lobe. Now let's talk about the first orbital of p, that is the px. Let's talk about px. Assume your nucleus is present over here. Now make one lobe of dumbbell in the positive x-axis and the another lobe on the negative x-axis. That's my px. Now let's move to the pz. Assume nucleus is present over here. Make one lobe of the dumbbell on positive z-axis and another lobe on the negative z-axis. So we got the dumbbell on the z-axis with nucleus at the origin. Now let's move to the py. Assume nucleus is present at the origin. Make one lobe of dumbbell on the positive y-axis and the another lobe on the negative y-axis. That's the py. Now let's talk about the d subshells, d orbitals. D orbitals also have directional preferences. And d orbitals are double dumbbell shape. Now let's firstly talk about dxy. I'm drawing dxy for you. Now both the dumbbells will be present along xy plane. In dxy I'm writing both dumbbells will be present on xy plane. I have already drawn the xy plane for you. The yellow part is the xy plane. So let's draw the dumbbells. Now one dumbbell will be present like over here between the x and the y, and the another dumbbell will be present over here again between the xy and nucleus at the origin. Now let's draw the y-axis. Now carefully check out the y-axis. Sorry, z-axis, z-axis. I got the z-axis. I'm so sorry, that's z-axis. Now you can imagine this diagram in the 3 dimensions. That's the dxy. Now let's move to the next one. Now this is the yz plane. So I'm writing my d is I'm going to draw the d y z. I'm writing both the dumbbells will be present on yz plane. I have made the yz plane. Now let's draw the dumbbells, the 2 dumbbells over here and between the y and the z axis. So nucleus is at the origin. That's the first dumbbell. That's the second dumbbell. Now let's draw the x-axis. That's x-axis. Hopefully you got this diagram in 3 dimensions. Now let's move to the next one. That's dz square. Now I'm drawing dz square. Less nucleus is present over here. The lobe will be present on the z-axis. Lobe is present on z-axis. It's also a double dumbbell, but another dumbbell will be present as a ring over the first dumbbell. So that's the dz square. Now let me draw the x-axis and the y-axis. That's x-axis. That's y-axis. Now let's move to the dxz. I'm writing dxz. Here both dumbbells will be present on xz plane. Now less nucleus is present over here at the origin. Now that's the first dumbbell between the x and the z axis, and this is the another dumbbell between the again x and the z axis. Now Let me draw the y-axis. So hopefully you got this thing in 3 dimensions. Now finally move to the last one, dx square minus y square. dx square minus y square. So let's nucleus is present at the origin. The first dumbbell is on x-axis and the another dumbbell is on the y-axis. That's dx square minus y square. So these are the shapes of all the orbitals that we have evaluated from the magnetic quantum number. So I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.